Hi everyone, welcome back to Fresher to Engineer YouTube channel. In this video, we are going to learn about domain name system. Domain name system, also known as DNS. DNS is a hierarchical and distributed naming system that translates human readable domain names into IP addresses. Imagine you are shopping online and type www.amazon.in into your browser. Within just few milliseconds, Amazon homepage appears. But have you ever wondered how your computer knows where Amazon is? Did your computer already know Amazon's IP address? Is there one giant DNS server somewhere on the internet that stores every website? Who owns the DNS? There can be multiple such questions. By the end of this video, you will understand the complete journey from your laptop to DNS infrastructure that powers the internet. Let's first understand the problem that DNS solves. We humans are very good at remembering names. For example, we remember people by names like Bob, Sakshi. Computer work differently. Computer don't understand names. They communicate using IP addresses. Think of IP address as a home address of computer connected to the internet. If I want to send a letter to your house, I need your home address, not just your name. Similarly, when browser wants to communicate with Amazon, it needs Amazon IP address. So the question becomes, how do we convert names like www.amazon.in into IP address? That exactly what DNS does. You can think of a DNS as a phone book of the internet. Years ago, before smartphone became common, people used printed phone books. You search for person name and the phone book return their phone number. DNS works in exactly same way. Instead of returning phone number, it returns IP address. Many beginners imagine there is a huge DNS server somewhere on earth that stores every website, but that would be actually a disaster. If single server crashed, entire internet would stop working. Instead, DNS is a distributed system. DNS is a distributed system consisting of thousands of servers spread across the world. To make this system scalable, DNS servers are organized into the hierarchy. Let's understand this hierarchy. At the very top, we have root DNS servers. These root DNS servers are coordinated by Internet Corporation for assigned names and number. There are total 13 root DNS servers named from A to M. These are not just 13 physical servers. Each of the root server is replicated across hundreds of physical servers located around the world. You might wonder if there are 100 copies of root servers, how does your DNS resolver know which one to contact? Here we use Anycast networking concept. With Anycast, you can share same IP address with multiple servers located around the world. When your DNS resolver sends a request, Internet automatically routes request to the nearest best available root server replica. For example, if you are in a Mumbai, your request will be handled by nearby root server in India instead of traveling to another country. This makes DNS much more faster, highly available, and fault tolerant. Although our diagrams usually only show one root server, in reality there are multiple replicated root DNS servers spread across the world. Now, here is important point. The root DNS server does not know Amazon IP address. Instead, they know where the top level servers are located. These servers are also called as TLD servers. Example of top level domains are .com, .in, .org, .net. Think of root DNS server as a receptionist in the office building. If someone asks, where is Amazon? The receptionist replies, I don't know where exactly Amazon is, but you should ask in a .in department. The root server simply gives the direction. It does not answer the final question. Next comes top level domain servers. For our example, we are opening www.amazon.in. So the root level DNS server will redirect to .in top level DNS server. The .in domain are managed by Nixie. that is a National Internet Exchange of India. Similarly, different top level domains are managed by different registry organizations. Now, here is another important point. .in TLD server still doesn't know Amazon IP address. Instead, it knows which authoritative DNS server is responsible for Amazon.in. We finally reach Amazon's authoritative DNS server. This server is maintained by Amazon or the DNS provider that Amazon has chosen. The authoritative DNS server stores the actual DNS records for the domain. For example, it knows the IP address corresponding to www.amazon.in. So, if we summarize this hierarchy, each layer has different responsibility. Root server knows where the TLD servers are, TLD server knows where the authoritative DNS server is, and the authoritative DNS server stores the actual DNS records. This layered organization is called as DNS hierarchy. Now that we understand the DNS hierarchy, let's answer another question. How does your laptop even know which DNS resolver it should contact in the first place? Think about it. Before connecting to internet Wi-Fi, your laptop doesn't even have IP address gateway or subnet mask or not even the DNS resolver. So how does all this information magically appears? Imagine you are sitting in a cafe and you connect to cafe's Wi-Fi for very first time. At this moment, your laptop knows almost nothing about local network. This is where DHCP comes in. DHCP stands for Dynamic Host Configuration Protocol. Its job is very simple. Whenever new device joins the local network, DHCP automatically provides network settings back to the device. Typically, it includes IP address, gateway, subnet mask, DNS server, or DNS resolver. But here is another important question. Your laptop doesn't know DHCP server's IP address either. So how does it contact to DHCP server? So your laptop sends broadcast message with destination IP address 255.255.255.255 over the network. Think of it like entering the room full of people and shouting, "Is there anyone who can give me IP address?" Every device on the local network hears this broadcast, but only DHCP server responds to this request. The first message sent by your laptop is known as DHCP Discover. The DHCP server replies with DHCP offer saying, "Yes, I have available IP address for you." Your laptop then sends DHCP request indicating, "Great, I would like to use that IP address." Finally, DHCP sends DHCP acknowledgement confirming the configurations. After this exchange, your laptop now knows all four important pieces of information such as IP address, gateway, DNS resolver, subnet mask. Notice something very important. Your laptop still doesn't know root DNS server. It does not know TLD server. It does not know authoritative server. It only knows the DNS resolver server's IP address. DNS resolver is responsible for communicating with rest of the DNS hierarchy on behalf of your laptop. Now your laptop knows where to send DNS request. Now that our laptop knows IP address of its configured DNS resolver, let's follow one complete DNS lookup from beginning to end. Imagine you open your browser and type www.amazon.in. Browser does not send request over internet directly. First, it checks its own browser cache. Modern browsers maintain cache of recently visited website. If you are recently opened Amazon, then browser may already know its IP address. If IP address is found here, the DNS lookup is complete. No network request is needed. Suppose browser doesn't have the answer. Then it asks operating system. Your operating system, whether it's Windows, Linux, or Mac OS, also maintain its own DNS cache. Since multiple applications on your computer can use DNS, operating system keeps a shared cache. If operating system finds IP address, it immediately returns it to browser. Again, no DNS request is sent over the internet. Suppose operating system also doesn't have the answer. Now only does your laptop send DNS request to DNS resolver. For most DNS lookups, this request is sent using the UDP protocol. UDP is a lightweight and fast because it doesn't establish connection before the sending data. Since DNS queries and responses are usually very small, UDP is an ideal protocol for DNS lookups. The request reaches the DNS resolver, but the DNS resolver checks something before contacting the internet. It first checks its own resolver cache. Remember, thousands or even millions of users may have recently visited or requested www.amazon.in. If another user has already looked up the same domain recently, then Resolver may have already known the answer. If the answer is available in Resolver cache, it immediately returns IP address to your laptop. Root server, TLD server, or authoritative DNS server are never contacted. This caching significantly reduces internet traffic and makes DNS much faster. The resolver sends query to nearest root DNS server. Remember, thanks to Anycast, the request automatically reaches nearest root server replica. The resolver asks, where can I find information about .in domain? The root server replies, I don't know Amazon IP address, but these are the top level domain servers responsible for .in domains. Notice something important. Root server never forwards your request, it simply returns the referral to appropriate TLD server. Resolver now contacts the top level domain server. It asks who is responsible for Amazon.in. The TLD server replies, I don't know Amazon IP address, but here is an authoritative DNS server responsible for Amazon.in. Again, notice that TLD server also doesn't know the IP address. It only knows where to find the authoritative DNS server. Now Resolver contacts Amazon's authoritative DNS server. It asks, what is the IP address for Amazon.in? This time, authoritative DNS server has the answer and it returns the IP address associated with www.amazon.in. The resolver stores this response in its own cache for future requests. Then it sends the IP address back to your laptop. Your operating system may cache the result. Also, your browser may cache it as well. That's why when you visit a website second time, the lookup is much faster. Once browser receives the IP address, it establishes new HTTPS connection over the TCP to Amazon server using destination IP address. Then it sends the HTTP request asking for web pages. Then Amazon server responds with HTML, CSS, images, and other resources that are required to display website. So remember, DNS translate domain names into IP address. And this is how all DNS lookup works. Now that we understand how DNS works, let's see how you can buy and register your own domain. Suppose you build your own website, let's call it as pressure2internet.in. How does this domain become part of internet DNS system? Many beginner thinks they need to contact ICANN or the root servers, but that's not how it works. Instead, you have to purchase your domain through domain registrar. You visit the registrar website and search for domain name you want. The registrar checks whether that domain is already registered. If the domain is available, you simply pay the registration fee. After the registration is complete, registrar securely updates the appropriate registry. Since our example uses .in domain, registrar updates .in registry, which is managed by Nixie. Congratulations, you now own the domain, but there is still one more step. If someone opens pressure2engineer.in, the website still don't work. Why? Because DNS system still doesn't know where your website is hosted. Now you need to configure your DNS record. If your website is hosted on AWS, you can use Amazon Route 53 as your authoritative DNS server. Instead of maintaining your own DNS server, AWS stores and manages DNS records for you. For example, you might create a record that maps your domain name to your web server's IP address, or you might point your domain to AWS load balancer using other DNS records. Now, whenever someone looks up pressure2internet.in, DNS Resolver eventually reaches your authoritative DNS server, which in this case is Amazon Route 53. Amazon Route 53 returns the correct DNS record, allowing browser to connect to your website. And that's how your domain becomes accessible from everywhere in the world. Let's quickly summarize everything we have learned today. We started by understanding why DNS exists. Human remember names while computer communicate using IP address. DNS bridges that gap by translating domain name into IP address. We then learned about DNS hierarchy. At the top, we have root DNS server. Below them, we have top level DNS servers, also known as TLD servers. Finally, we have authoritative DNS server that stores actual DNS records. Next, we learned how our laptop discovers IP address of a DNS resolver using DHCP protocol. We then followed complete DNS lookup. Browser check its cache, then operating system check its cache, then request reaches to DNS resolver, then DNS resolver check its cache. If necessary, resolver contact root server, TLD server, and finally authoritative DNS server. IP address is returned to browser, then browser establishes HTTP connection to website. Then we finally learned how to purchase a domain through registrar and configure authoritative DNS services like AWS Route 53. I hope this video helped you to understand how DNS works from start to finish. If you found this video helpful, like the video, subscribe to Fresher to Engineer YouTube channel. Thanks for watching. I'll see you in the next video. Bye bye.